Hi, in this video we want to talk about the quadratic function. Now the quadratic function is something that you're used to at this point, and it mostly took on this format. So a in this format represents or shapes the shape of our function, whether our function is going to be happy or whether our function is going to be sad. This all depends on the value of a. When a is positive, we get this shape, but when a is negative, we get that shape. B we don't really concern ourselves with, but B is especially useful when we're trying to find the coordinates of the turning point. This is because B is responsible for the horizontal shifts. And when we use B in conjunction with A, we get the formula x is equals to minus B over 2A. This formula gives us our x value of the turning point on our function. So that's another useful formula to remember under this topic. So we have x is equals to minus b over 2a. Then moving on, if we manage to factorize our function, we will land onto this format where again we have a representing the shape of the function. Is it smiling or is it sad? Then we have x1 and x2. x1 and x2 are variables that take the place of our x-intercepts. So they represent our x-intercepts, or basically where our function will be equal to 0. And how we get these values is either through factorization and then finding the values themselves, or we use what's known as the quadratic formula, which is x is equals to minus b plus minus b squared minus 4ac all over 2a. And this formula, we mostly use it whilst our function is still in this format over here. Then we can take our quadratic function while it's in this quadratic format, and we can convert it into its turning point formula. And we do this by following a process called completing the square. So by completing the square, we end up with this format over here, where again a still represents the shape of the graph, but here I forgot the square, but we still have these new additions. So we have minus p and we have plus q on our on the function format. And we see over here on the drawing that p and q correspond to the x and y values of our turning point. And then again, it's necessary to stress that whenever we have a minus p, whenever we have a minus anything or plus anything within these brackets, we have to equate it to 0 so that we get that it's actually the opposite sign. So for example, if it was x minus, let's say 2, then this would be positive 2. We wouldn't draw it over here as negative 2. That would be incorrect. So yeah, that's something that is worth stressing and worth remembering as well. So whenever you have a minus, and generally this is true for any which case you may have, whenever you have a minus and you're dealing with horizontal shifts, it's a shift to the right. But whenever you have a plus, like a plus plus 1 or plus 3 or whatever plus it is, then it's to the left. So it's kind of counterintuitive, but plus is up, minus is down. But when it comes to horizontal shifts, plus is to the left and minus is to the right. So that's it for quadratic functions. These are the formulas that you're mostly going to work with. You might see quadratic functions and linear functions popping up when you do calculus and differential calculus actually, but we're going to deal with that when we get to that section.